In this problem, we need to determine the equation of a circle which passes through the point 2, 1 and is tangent to both the axes. So let's try to understand the problem graphically. So here we have a Cartesian plane with the x and the y axis. Let's try to sketch a circle which passes through the point 2, 1 and it touches both the x and the y axis. We'll consider that this is our circle and this circle is passing through the point 2, 1. We need to determine the equation of this particular circle. So let's consider the center to be h, k, and we'll also need to obtain the radius of the circle. So why we need these two information, that is the coordinate of the center c and the radius r, because that is going to help us obtain the equation of this particular circle by using the standard form. So let's specify the standard form of a circle. Suppose we have a circle whose center has the coordinate h, k and the radius given by r. Then the standard form of a circle is given by this particular equation, x minus h whole squared plus y minus k whole squared equals to r squared. Fine. So let's try to find out the value of h and k. That's very simple. All we have to do is consider the center c and we're going to drop a perpendicular on both the x-axis as well as the y-axis. Now this is going to be the radius of the circle, but then again this is also going to be the value of k, the vertical distance from the x-axis, and the horizontal distance from the y-axis is going to give us the value of h. Now that means if we consider the radius to be, let the radius to be r, then we can say that the value of h, that's going to be equals to the radius of the circle r, as well as the value of k, that's also going to be equals to the radius of the circle r. Now that we have the value of h and k, which is represented in terms of the radius r, we can use the standard equation. So we have x minus h, so h value is r, so we have x minus r whole squared plus y minus r whole squared, and this is going to be equals to the radius of the circle. So let's label this as equation number 1. Now we'll try to find out the radius of the circle. Here what we can do, we can use the distance formula because we have the point c, which is h, k. So h, k is nothing but r, r. So this is one point, and we have the other point. So let's call this point as p. So the coordinate of point p that's given to us, that's 2, 1. And when we join the point c and p, that is nothing but the radius of the circle r. So here what we'll do, we'll use the distance formula. Then we have r equals to square root of, all we have to do is take the square of the difference of the x coordinate first. So we'll take r minus 2, square it, and add it to the square of the difference of the y coordinate. So that's r minus 1 whole square. Now we'll have to solve for the value of r. So r comes out to be equals to, there will be two values of r that was possible. One will be r equals to 5 and r equals to 1. So that means we have two radius, which tells us that actually there are two circles. The r value is 5 units. Then the center, which is h, k, so that is given by 5, 5. In that sense, equation 1 can be now rewritten as x minus h, so x minus r. So in place of r, we'll replace the value with 5. So we have x minus 5 whole squared plus y minus 5 whole squared. That's going to be equals to 25. So this is one solution. And when we have r value equals to 1, so when r equals to 1, then the center of the circle is going to be given by 1, 1. And in that case, equation 1 will be x minus 1 whole squared plus y minus 1 whole squared equals to square of the radius. So that's 1. 1 squared is 1. So we have two equations. So there are indeed two equations possible, two circles possible. So let's try to look at the diagram. So here we're taking the help of an online graphing calculator, Desmos. So the red circle that has the equation x minus 5 plus y whole squared plus y minus 5 whole squared equals 25, meaning the circle has the center f5, 5 and its radius is 5 units. And then we have the smaller circle, the blue circle, whose coordinate of the center, that's 1, 1, and it has a radius of 1 unit. And in both the two cases, for the two circles, we see that it passes through this common point, which is 2, 1. In fact, there is one more point While this is not provided to us, but from this graph we can observe that there is another point which is 1, 2. The circle also passes through that, but the two circles pass through this common point. This is the solution to our problem.